Hi. Next, we are going to see the priority encoder. You all know the formula for the encoder. Encoder is nothing but 2 power n input and n output. And additional with your output, you have one bit is called it as valid bit. So when the valid bit is equal to 1, when your input is 1 or more than 1, then the valid bit is equivalent to 1. So initially all the inputs D0, D1, D2 and D3 is equivalent to 0 and your valid bit is 0 and your output is XX. It's nothing but your don't care condition. If your D0 is 1, your output is 0, 0, valid bit is 1. If your D1 is 1, output is 0, 1, valid is 1. If your D2 is 1, output is 1, 0, valid bit is 1. If your D3 is 1, output is 1, 1, valid bit is 1. And if you see D1 is equal to 1, 1, the previous bit is considered as a don't care. If D2 is 1, the remaining 2 bit is considered as the don't care. If D3 is 1, the previous 3 bit is considered as a don't care condition. Just I'm taking this table and I'm going to expand this table. So initially if it is 0, 0, 0, 0 and your output is don't care and valid bit is 0. And next is D0 is 1, output is 0, 0, valid is 1. Next D2 is D1 is 1 and D0 is don't care condition. Now I'm expanding this. D1 is 1, D0 is don't care actually. So for the don't care, initially I'm writing as 0, the next one is 0. So the remaining 2 bit is 0, 0. D1 is 1, D0 is 0, D2 and D3 is 0, 0. Similarly, D0 is 1, D1 is 1, D2 and D3 is 0, 0. So what is the output for this one? If D0 is 1, output is 0, 0. D1 is 1, output is 0, 1. So D1 is 1 means your output is 0, 1, valid is 1. Just like that, if your D2 is 1, you have a 2 don't care condition, right? So that 2 can be replaced in 4 different values. 0, 0, 0, 0, 0, 1, 1, 0, 1, 1. And this is 1, 0 because D2 is 1, 1, 1 and D3 is going to be 0. Your output is 1, 0. Valid bit is 1. Next is D3 is 1. The remaining all don't care. So just like that, your D3 is 1. Remaining all don't care. So I've started with 0 and I've written as 111 and your D3 is 1. Your output is 111. 111 in the sense this is 1, 1 and your valid bit is 0. So like that you have to rewrite the first truth table as like this. The next is you're going to do the K-map. Based on the truth table, I have drawn the K-map. So first is if you see this, for the y1, 0 is don't care. Next, I have written the equivalent decimal value. 2 means 1. From 2 to 2, 6, 10, 14, 1, 3, 5, 7, 9, 11, 13 and 50. For all the values, your output is going to be 1. Except 8, 4 and 12. This is for y1. Except 8, 4 and 12. The remaining all 1 and 0 is don't care condition. So I am grouped as 8, 8. So your answer is D3 plus D2. Like that you have to do the K-map for Y0 as well as you have to do for the valid bit. After completing the K-map, based on this you are going to draw the diagram. So for what and all you are going to draw the diagram? Y0, Y1 and V. Y0 and Y1 is going to be the output and V is nothing but your valid. So based on your output from the K-map, I'm going to draw the diagram. For Y0, D3 plus D1, D2 bar. So D3, D1 and D2 bar. So this is nothing but Y0. Next Y1, it's nothing but D3 plus D2. This is D2 plus D3. What about V? D0, D1, D2 and D3. So D0, D1, D2 and D3. This is the output for your valid bit, and this is the entire diagram for your priority encoder. Thank you.